Howdy, y'all. Welcome back to our interactive algebra worksheet. Today we'll be talking about reasoning with equations and inequalities. To begin, we're going to start with some vocab and general review. So let's start with an expression. So an expression is something we hear a lot in math, but to formally define it, we can just define it as a collection of symbols. And when I say symbols, that includes letters, numbers, Greek letters as you move higher up, but a collection of symbols that represent a value. That represent a value. Now, some examples of that might be 7. Let me do it in a different. The number 7 can be considered an expression. 7x represents a value. Even when you look at the circumference of a circle, we have 2 pi r. And as you get higher up, these expressions can get even more and more wild and lengthy. Now we move on to our equation. We generally define an equation as a statement that says two expressions are equal to each other. Expressions are equal. I'm just going to write are equal to each other. Now, you might have seen examples of this when you say something like 7 equals 7. The simplest of all time. 7 is equal to 5 plus 2. And we even get more complex when we say things like 7x is equal to 12. Lastly, let's talk about operations. So generally, we define operations as mathematical procedures, things like adding or addition, subtracting, subtraction, multiplication. Actually, let me go ahead and write that out. I'll just write multiply and divide. But we don't talk enough about their inverse. So the opposite, the counter operation to adding would be subtracting. Vice versa, for subtracting, the inverse operation would be addition. Take some time and see if you can figure out what the inverse operation would be for multiplication and division. Okay, if you got the correct answer, you had some time to think about it, you should have gotten that the inverse of multiplication is division, and division inverse is multiplication. That's important as we move forward. So let's go ahead and work through a problem. So the idea here is that we want to isolate this variable right here. We want to isolate that variable on one side of the equation and everything else on the other side of the equation. So the first thing we notice is that you have all this to work with, but notice that you have this 4 multiplying this entire quantity. So we want to move this 4 to the other side. In order to do that, we need to do the inverse operation. So we divide by 4, so that now becomes a value of 1. And since this is an equation, what we do to one side, we must do to the other. We also divide this side by 4. We're now left with the quantity x minus 2 is equal to 16 divided by 4, which simplifies down into 4. Last but not least, we notice that the only thing left is this 2, which is being subtracted from x. In order to move it to the other side, we do the inverse operation. That becomes 0, a 0 term. Add 2. Our final answer, x is equal to 6. Alrighty? Now, here's a chance for you to attempt it on your own. Remember, we want to try to isolate this variable. So go ahead and Try that now on your own. Okay, hopefully you've had some time. The first thing we notice, this 3 is dividing the whole quantity. So in order to get rid of that, we want to multiply by 3. That becomes a value of 1. So now we have to multiply this side by 3. Our new equation becomes x plus 7 is equal to 18. Remember, we're still trying to isolate this x, so we must get rid of this 7. In order to do that, we subtract by 7, the inverse operation. This becomes 0. You subtract by 7 here. Our final answer, x is equal to 11. Hopefully you're able to work that out and get that answer on your own. Lastly, here's our expansion. I would like you to think, using the methods that we've been using for this entire video, how can we use those methods to approach this problem? Take some time, write a bit about it, and think it out, and I'll see you in class tomorrow. Goodbye.